Hi, good morning. Nice to see so many people at that early time. I hope you're more awake than I am. And let's see what happens in the next 45 minutes. So, I'm going to talk about Buildpacks, what that and how does it work. Who of you uses Buildpacks already? Nobody. Okay, cool. So, I try to be as slow as possible. If you have any questions, just raise your hand during the talk. I'm more than happy to answer them at the time it occurs at you. So the boring part about me, I'm Michael. I am a Java champion and I work at InnoQ. We are a mid-sized German consultancy doing everything around software architecture, software development, trainings, consulting. Yeah, what you can imagine. And let's dive into the topic. What's our problem? Our problem is we have our source code. During the last decade, I think most of you have more than one code base. Maybe you have one, but I have usually multiple ones. And this source code I want to deploy somewhere. So we have some kind of runtime where our application runs, and the application only provides business value if it runs and is used. And how do we get from the one side to the other side? And as we are using slides, we can just add another box with a question mark. So how do we do it? Okay, we use some kind of pipeline. I mean, when I started like 15 years ago, some projects, all the source code were hand-built and it took many times, but in today's world, most projects I see, or every project I see, has some kind of automated workflow in a pipeline that takes the source code, does something, and provides an application. And on the runtime side, today, most applications, at least I stumbled upon, are in some kind of container image and built as a container image. Then and in the at the runtime, a container is started, and there we use Kubernetes, ECS, whatever you like. I mean, everybody of you is using container images. Who's not? Okay. Yeah, there are cases where we still use an application server or stuff like that, but Buildpacks is especially for container images, and therefore we only provide that view of the world. And now another question arises. What do we do in the pipeline to build a container image? And the solution that I started with when all the container stuff started getting traction is, yeah, we write a Docker file. Everybody of you has seen a Docker file? Somebody who's not seen it? Okay. So it works. Maybe. I'm not sure about the command with the newer Spring Boot versions, but there may be some problems. For example, does anybody in your team have the knowledge to write a Docker file and maintain it? Because, I mean, that's more or less simple, but even that requires a little bit of knowledge and shell knowledge, and if you do some more fancy stuff, it gets more and more and more, and at many of our clients, the knowledge is just the basics. And you need to build more knowledge. Or you have one person who knows it, and if that's on holidays or something like that, and something happens, you have a problem. Then there are some things as caching. So Docker or containers use layers, and layers can be cached and reused. And first of all, that can lead to problems that you're using a cached layer, but you expected it to be a new build layer because something changed. So for example, if you just have run get update somewhere and you execute it the second time, that line does nothing because the line has not changed and it takes the layer from the cache, and you expect it to have an updated version of your packages, but you don't have. And not that, but you want as few layers as possible, and you want the layers in the correct order, so the ones that change often are on top of the stack, to reuse as much caching as possible. So that has to be in mind too. And then there's stuff like the pit 1 problem. So depending how you start your process, it may be that a sub-process is spawned within Linux, and then you are not the root process. And if you try to stop the container from the outside world, the signals are not propagated to your application. And usually, the only way to check it is that if you do docker stop, it takes about 30 seconds, because Docker sends a stop signal. The application does not do anything. It runs and runs and runs, and after 30 seconds he's going to kill it with an even harder stop signal. So you have to be aware of all of that if you're writing your own Docker files, which is totally fine, and I do most of the time. And every time, especially my front-end colleagues stumble across such a Docker file, they often say, why isn't it as easy as with Heroku? Does anybody not know Heroku? Okay, so Heroku is a platform as a service which is 15, 20 years old, so they are pretty old. And they got famous, especially in the Ruby on Rails world. And their deployment model is just a git push, which is sliced up on the top. So you do a git push to a repository on their side, to a remote repository on their side, and then their side starts to build your project, and it magically detects if it's a Java project, if it's a Ruby project. It detects, oh, it's using Maven, so I should execute Maven. And out of thin air, the compiled application appears and can be started. And they are doing that since, I think, 15 years. So back in the time, that was the easiest solution deploying something, just doing a git push and everything is done for you. I mean, if you need to do some fancy stuff, it gets complicated, and Heroku has its own drawbacks, of course, but that's was pretty amazing at that time. And as you can see here, they are already now talking about we are using some kind of build pack. So basically, build packs were invented at this Heroku platform as a service before they were even named build packs, and they have evolved from Heroku to the world. So after Heroku, some other vendors like OpenShift used the same technology, that they provide some pipeline logic that you don't need to write yourself, which detects what kind of application is in your repository and builds it for you into a runnable container, and then you can run that. And of course, if multiple vendors start using the same thing, sometimes they start donating their code, their knowledge, and the standard evolves. And that's what Buildpacks.io is now at times. So Buildpacks.io is basically just the specification of Buildpacks and the runtime behind it and around it, and some kind of tooling. And then there are multiple vendors who can implement the standard. And basically, you can pick and choose what flavor you like. And Buildpacks.io itself is part of the Cloud Native Foundation. The Cloud Native Foundation is what Eclipse or the Apache Software Foundation is for most of the Java projects. So everything that has something to do with cloud, more or less, is under the umbrella of the Cloud Native Computing Foundation. Speaking of vendors, there are 3 main vendors which support that standard. Of course, there is Heroku itself, because they are using it for 15 years. They are providing their own build packs, so you can use that. Then there's the Paketo one. The Paketo one is, yeah, I'm not sure if you can say, but like a reference implementation, which maintains production-grade quality. Paketo buildpacks are, for example, the ones used if you are using this Spring plugin, which I will show you in a few minutes. And the third big competitor is Cloud Foundry, which is also a platform as a service you can host yourself and you can deploy your stuff to, and they have their own buildpacks too. And there are other vendors you can use. Or if you use their platform, they use their own buildpacks. So I said Buildpacks itself is just a specification, and the specification contains some concepts. So the first one is we have a life cycle. So during the analyze phase, every buildpack is called, and then it looks at your source code and can detect, for example, oh, there is a POM XML. I need to run Maven within my build. So in the analyze and detect phase, this is done. Then there's a restore phase. In the restore phase, this buildpacks can restore layers from the last build. So you can use caching of your layers between multiple builds. So for example, if there's a layer where your dependencies are in, if the POM XML did not change from the last run to this, it could reuse the complete dependency layer because it can detect, oh, no dependency has changed, for example. Or if it detects your Java code has not changed, it could, for example, skip the compilation and reuse the last compiled classes. I'm not saying that any buildpack does that, but that's what's possible. Then there is a build phase where all the buildpacks that during the detect phase have said, oh, I've detected something I can provide to, will be executed, and here your code is compiled, packaged, some run information for the command line is written, and so on and so on. And lastly, in the export phase, everything that's done within the build phase is exported as a container image into a registry. And just as a shortcut, there's the create phase. If you are running the create phase, basically all the 5 phases below are run in order. Then there's a launch phase. That's the phase that's used to run your application. Although you can just use Docker run as you're used to, and this phase is more like an implicit one. Yes? Yeah, I think it depends on the build pack, but I think it depends on the build pack.
I think Maven and many others have these kind of checks to build
Yeah.
module something like that.
Did anybody not hear him? So I repeat. Firstly, he asked if the tools like Maven are used to check if in the restore phase something can be restored or some other mechanisms. And yes, buildpacks, it would depend on the buildpacks how it does it. And the second was that, for example, for the compiling thing, Maven does it all and maybe does a better job. Yeah, I think that example maybe was a bad one. The most common restores are something like, I downloaded the exact JDK in the last build. I don't need to download it again. So, yeah, more like in Docker containers, yes. And the last and special lifecycle phase is the rebase phase. And that's a feature I'm 50-50 about how I should feel about it. Within the rebase phase, you can change lower levels into your runtime images without rebuilding them. So for example, what this could do is, if there's a new JDK release, you could exchange the JDK layer in your runtime image without recompiling your application with that new JDK version. It can be a good way if you need to fix some security issue and don't have contact to all your teams, but I personally would like to rebuild my application with a new JDK, but it's possible. So use at your own risk. And then within that specification, there's a concept of a build pack itself. And the build pack itself does the whole work. It's more or less like a Maven plugin, if you like analogies. And a build pack itself consists of a build pack toml. A toml is like ini files in Windows format, more or less, which you can use for configuration and metadata, which is common in the cloud native and Go world, not so much in the Java world. But you will see an example later. And then the specification specifies there has to be 2 executable files within a build pack. That's bin detect and bin build. And we'll see how you can implement that later too. So it could be a shell script, a Go binary, a Ruby script, something that's executable and can be called from the shell. And then there are some more concepts, and that's how it all is assembled. There's stack, builder, and platform. So I have a build pack, but normally one build pack is not enough. Sorry, I'm too fast. You have a build image. So as you will see, when I execute a build pack build, it all runs inside a container. And that container contains the life cycle phase, because there are several versions and they are updated, and maybe there's another phase in the future. And within this build image, this life cycle runs, and this life cycle runs every build pack. And the build image needs to contain the tools you need to execute your build packs. So there are build packs who itself use Ruby. And to be able to execute build packs who use Ruby for their own logic, you need to have Ruby installed within your build image at least. So that's your builder, like your normal PC where you install your tools. Then there's the run image, and the run image is more or less the base image of your build container image. Yes? Yeah, the question is, can you define your own base build image? Yes, you can do. There, for all the tools I have, they have their own build images you normally use, but if you need to, you could use your own. But only the tools for the build packs are in there. So if you need another JDK, that's done inside the build pack and not inside the build image. So it's only the tools for executing your build packs, yes? Yeah? Yes, that is only build pack naming, yeah. And a few versions ago, that build and run image was called a stack as a pair. Because normally the build and run image, they need to be somewhat aligned to each other to work within the build pack. So you should not interchange them to be them completely different. But that's a thing I've never done. I'm normally using the provided ones. And the whole one then is called a builder, because that's everything you need to build your application. And not only you don't need one build pack, normally multiple build packs will be provided during your build, because every build pack does one very specific thing. So, for example, there's one build pack for installing your JDK. There's one build pack for executing your Maven build. Then there's one build pack which detects, oh, it's a Spring Boot application that has a runnable jar. I know how to run it. Then maybe there's another build image, oh, I can create an S-bomb for you. And so, yeah, I think in the standard Spring Boot case, which we will see later, there are 6 build packs normally who provide something to the build. Yes? To be honest, I'm not 100% sure, but as of my understanding right now, all the build packs are executed within your build image, but not as separate images. But I'm not 100% sure, so don't pin me on that. And then I forgot to internationalize it. Then you have your source code, who's outside of your builder. And yes, as I said, the lifecycle is contained within the builder and the build image. And all of that together is called a platform, which is a little bit misleading. And platform, even the command line tool you can use to build your build packs is called a platform. And for me, a platform is always something on the server side which runs permanently. But yeah, naming is hard in our industry. Okay, so no questions right now? Okay, so examples. Because I'm mostly using Spring is not the best framework out there. There are multiple others. Choose whatever flavor you like, but I use Spring and I'm most sufficient there. And Spring has built-in support for build packs. There is that blog post that if you're using a pretty, let's see if I can do it full screen, no. If you're using an older Spring version, below 2.7.18, 3.13 and 3.16, you need to customize something because some version clash ups, but normally you can use a Spring out of the box. And I have a Spring, I hope it's large enough. I have a normal simple Spring Boot project right here. And you could use a Docker file. That's the one shown on the slide. So we could use that, but I will not execute that because it's not that fascinating. But let's start with build Maven. So when I talk about Spring has built-in support for build packs, there is a Maven plugin, the Spring Boot Maven plugin, and that has one goal, build image. And we can execute that and hope that the internet works. Yes. So it's compiling my application, and now it's building the image with build packs. And there you can see it's pulling the builder image, builder yummy. Builder yummy base. So that's my builder image, and you could override that. And then it's pulling, and then it's executing the life cycle in version 0.19.3. And then it's analyzing some stuff. It's detecting 6 build packs, CR certificates, so SSL, HTTPS certificates are additionally installed. Then it has decided I need a JDK, in that case the Belsoft one, the Belsoft Liberica. It's using Sift. I think Sift is for SBOM and some security stuff. It detects that we are building an executable jar, something with a distzip, and it has detected their Spring Boot. And then you can see it's restoring some metadata, and then it's building, and every build pack here says at least that it's running. And some build packs tell you if you need to enable debug, you could have set an environment variable BPL debug enabled, and then the build pack would have done something different. For example, opened the JMX or the debug port. Yes?
It stated that it used 6 of 26 build packs. What is the 26? Is it specific to Maven build, or is it the whole?
Yeah. So the question was, it was saying 6 of 26. So what are the other 20? And if you look at, this is the GitHub repository for the builder, and the Paketo build packs builder yummy base says, where is it? Paketo builder documentation. That's the I had it open. Okay, I cannot prove it, but to answer that question, the other 20 are, for example, for Ruby, Python, PHP, because it's not a Java, Paketo and Buildpacks is not Java specific. And that builder can be used for building nearly every other language too, and for the other languages, of course, other Buildpacks are used.
Okay, so just for clarification, for example, we would have one Buildpack specific for Jakarta builds, it's not using Spring Boot.
I'm not sure if there is a Jakarta EE, but yeah, if you maybe if you compile a Jakarta EE application, you would have another Buildpack. Or I'm seeing. Oh, maybe I have to plug in power, which I forgot. Sorry, but we have 30%. So that's one way of building, and you could now build the same application, for example, with Paketo. And for building with Paketo, you can, for example, use as a platform Pack. So Pack is the reference implementation CLI tool for building Buildpacks if you don't have something like that Maven plugin. And here I specify the path to my application, which is in the current directory. As a builder, I would like, in this case, to use the Tiny Builder. So the Tiny Builder is a more stripped down version and maybe supports a little bit less. Pull policy is just because in talks you sometimes have no internet, and it's good to not check if there's a newer version. And in this case, because I need to specify that the JVM version is 21, because by default it would use JDK 17. That's the reason why there is a system properties, because I think the Heroku Buildpacks, for example, look into your system properties to detect which Maven version you are using and which JDK version you are using. So it might, the Buildpacks are not completely interchangeable, of course. I mean, the whole is standardized, but you know it, every specific implementation is their own. And while it runs, sorry, but I have no power. Okay. If it shuts down, we will fix it. Yeah, now you're seeing, okay, I built it in the hotel to just be sure that everything works. So it's reusing all layers from the cache. So it basically does nothing. But we can see even that one, okay, it's the Paketo one, so it uses the Liberica too. So basically, it did the same, but was not started with a Maven image. Okay, so any questions? More questions? Yeah?
You are building it with your local Docker environment. Is it possible to put it or pass it to a remote Docker engine?
Yeah, should be.
We have many colleagues or many customers that have no access to Docker engines.
Yeah. Yeah. So the question was, I'm using Docker locally. If it's possible to use remote Docker machine as a build, yeah, should be possible or must be possible. Okay, so then, no, not the example in a demo. So the second thing I want to show is how to write your own build pack. Although I would imagine most of us don't ever need to do it, for me it was nice to see how it really works, just to get a grasp and what it does. And so I like to find out how things work. And I can't enter presentation mode. Okay, so sorry, okay, I'm a little bit nervous. We'll see. So in this case, I have an application which is just application with a public static void system print out hello world. So the simplest possible. No, nowadays I could skip the class, but that's another topic. So, and we have a folder which contains 2 build packs, JDK build pack which we will build, and app build pack. And as seen on the slide, every build pack at least needs these 3 files. So for example, for the JDK build pack, there's a build pack toml. And there say this build pack requires the API in version 0.10. It has an ID, which I forgot to change, but it doesn't matter. It's JCON, JDK, or JavaLand JDK, and my version is 0.01. And then there's a detect script, which in this case, for demo purposes, we will use bash. Don't worry if you're not a bash expert. If there's something slightly complicated, I will explain it. And then there's the build script, which as well is a bash script. And for the application, it's the same. So there's also a build pack and the both scripts. And we could now use that build packs to build our application. So we are using pack to build our app. Our source code is within the app folder, and I want to use the sample builder Yummy. That one is an even more stripped down builder, which don't contain any build pack itself. So it contains only the build packs I specify, which is the JDK and the app one, and as well the build pull possibility to not pull. And we can build now. And then we are seeing the detector has started. It has detected our own build packs. It's restoring, and we see building JDK, building application. That was the echo parts in the builds in the detect scripts, in the build script, sorry. And then something is built, and yeah, we would have an image, but both scripts did nothing, so we basically have an empty container which we cannot run. So to start, we need to add some code, and we start in the detecting of our application. And for this example, I look if in my application there's an application.java file, and if it's not there, that is a not file, then I will exit with 100. And this would lead to, if this file application is called, I need to move. So now it's application 2. And if I build them now, our build will fail because no build pack was detected, because our JavaLand app exited with 100. So it said, there is no application Java, I cannot do it, please exit. And then we need to build up a so-called build plan. So within every of the detect files, if you're detecting that your build pack will run within the build, you can append data or additional information to the build plan. And the build plan is more or less a file which is passed as this environment variable. And I write into that file requires, and then that's toml basically. My build pack app requires that there is another build pack JDK. Or not a build pack exactly, more or less I require the tool JDK, which should be provided by another build pack. And for our case to work, so I need to change the JDK detect to, and our JDK detect build pack writes into the same build plan that it can provide a JDK to the build. So if I run my build now, okay, 19%, you can see that at least that both build packs are run, because the application build pack says, hey, there's an application Java I should run, and I need a JDK. and then the JDK one has said, oh, I can provide a JDK, so everything that's required is also provided so it can run. So next step. And that's everything we will do within the detect phase in our case. So that's pretty simple, and it could be way more complicated, of course. So for building a Java application, we use Java-C, and we compile our application Java class into some directory, which is called layer app. And that's the second concept within a build pack. So there is a layers dir, and inside that layer dir, every layer you want within your build or your runtime image, you need to create a new directory, in that case app, and you need to add a file with the same name, so app toml, so that both match. In this case, I say this layer app should be within the launch phase, within the launch image, and therefore it is copied after the build finishes into your runtime image. And I'm compiling my application directly into that image. 6, okay. We could execute that too. 16 persons, okay. And in that case, now our builder cannot run because Java-C is not found, because the JDK image does nothing. So we need to build the JDK. And in this case, I'm downloading it from my local machine because internet and presentations is hard. So I have locally put that file and started a JWeb server. And I'm creating a JDK layer. And in this case, I need the JDK to run my application, because in Java you need the runtime for runtime. And I need that layer within another build pack too, so that layer can be used within the build phase too. So it basically is used in two locations. And then I create my layer, I download my JDK, I untar it with some magic flags to have everything in the right location. So if we are executing that now, yeah, you see, installing JDK, now it's downloading, it's compiling the sources. And yeah, the application is built. And if I would run it now, docker run JCON app, it cannot launch because my build packs have no magic to detect what or how to run my application. I'm pretty nervous right now. But let's see, what was 7? I think that's okay. So within the build of no, that belongs into the app. Yeah. So within my application, I can create multiple layers. And in this case, I create a second layer, the launch layer, which is standardized to the launch phase. And I don't need any files inside that, but I need that toml description. And within that, I say in this layer has a processes. It's of type worker, so there's type worker and type web. And my command for starting it is java-class pass my layer of the application and the application main class, and that's the default command. So I can build it again. Yeah, now it's installing the JDK again. Compiling. Yeah, and now it magically works. And so the last step we can use is within the JDK. Need to switch again. Yeah, low battery. I can implement caching, and I will explain it now. So when my build run, I look if there is a JDK.toml from a pre-run, and then I use JQ, which converts YAML to JSON, and then I use YQ to convert YAML to JSON, and use JQ to which is like XPath for JSON, to find the metadata JDK URL. So I have the one from the JDK toml and the one I downloaded from. And I write my JDK URL here, and then I can, as a last step, say when the new JDK URL is equal to the cached one, I'm reusing the cached JDK, and when not, I will install it. And we can now build 2 times, I think. Yeah, and that's here. So because I'm previously not done that caching, it says there is no JDK toml from a previous run, and therefore I'm installing the JDK. And now on my second run, you can see it's reusing the cached JDK. So to summarize, Buildpacks are a magic way to build your application, or to get from your application source code to your application without writing your own Docker file. So you rely that other people who know what they are doing provide some build steps to your build. You can use the provided ones from Paketo, from Heroku, from Cloud Foundry, or whatever you like. You could write yourself. And if you write yourself, I've basically shown it to you. So you need these 3 files. You need some logic to detect if the build pack should run. You need to implement the logic to execute your step. And if you're not liking shell scripting, like in this example, there is a Go library which can be used. So you're writing Go and reuse a library which where you can say just cache that layer, and it knows what to write into the YAML file, the toml file. And if you don't like Go and would like to use Ruby, there's a Ruby library from the Heroku guys as well, where you can write your build packs with a Ruby library. So that's possible. And usage, or to use it or not to use it, for my projects, because I really like to have everything in hand, because I have a false sense of safety, I like to write my own Docker files. But as a bigger an organization grows, and when you have a dedicated build team who's responsible for multiple teams, it gets more and more worthy using something like Buildpacks, so that not every team does need to stay up to date at how to write Docker files, how to pack your application, how to generate an SBOM, and so on and so on. So it's on your side to decide if you want to use it or not. And yes, thanks for listening. I'm here till afternoon, so if you have any questions you would not like to state now, you can approach me, ask me. Thanks for listening.